This is Agriculture Today, and I'm Shelby Varner with the K-State Radio Network. Jeff Whitworth, Kelsey Andersen, Onofre, and Sarah Lancaster begin today's show with two segments discussing the issues volunteer wheat can cause and how it can be controlled. These K-State specialists explain the various pests that can live in volunteer wheat and what they can vector to create ongoing issues. Sarah also states what chemical management growers should consider. K-State dairy specialist Mike Brouk ends the show discussing the importance of fan maintenance. He says just a small amount of dust on the blades significantly reduces air movement and increases energy costs. That and more is coming up ahead. You're tuned in to Agriculture Today, and we start our Tuesday show talking about controlling volunteer wheat and why it is important with K-State crop entomologist Jeff Whitworth, K-State wheat pathologist Kelsey Andersen Onofre, and K-State weed specialist Sarah Lancaster. Jeff, Kelsey, Sarah, I appreciate you all taking the time to join us today.
Good morning. Our pleasure. My pleasure.
Thanks for having us over, Shelby.
Jeff, when we're thinking about volunteer wheat from the entomology side of things, what should people be considering?
Getting rid of it at least 2 weeks prior to planting and keeping it gone as much as you possibly can. Actually, as far as wheat pests go in the world of insects and mites, probably the number one pest we've had over all the years and around the country, around the state, is the Hessian fly. And the Hessian fly, I'll talk about that a little bit because we have 2 to 3% infested fields in every field in Kansas with Hessian flies. Occasionally, it will infest more, and it can really do a number on a field. The Hessian fly has to have wheat. In Kansas, that is the only crop that we've ever found them in. There are a few other minor hosts, but wheat is the main one. So, and we always talk about the green bridge. The green bridge is, from the wheat dies down until you plant it again in the fall. That period of time in those areas where wheat was, and there isn't any, if you let the volunteer grow, that's what a lot of pests, in this case, have to sustain themselves. The Hessian fly, it has been a perennial problem since it was first introduced into Kansas. Back in the 1800s, actually. I saw a few fields in 2025 that were replanted in the fall because of Hessian fly. They have to have the green bridge. They have to have that period of time when there's some volunteer wheat growing to sustain the population. So that's our number one pest. If you've never had a Hessian fly problem, you don't realize what the problem is and you don't think about it. But then when you have it, you go out just about the time when you're getting ready to harvest your wheat and the wheat looks like pickup sticks. And a lot of times the growers think maybe they had a hailstorm go through there. It's easily distinguished or differentiated between hail and Hessian fly because if it's Hessian fly, it'll look like pickup sticks. If it's hail, it's usually all broken off in one direction. But you can always pull the stems up and you can see the little area where there's some flaxseed or have been some indication of feeding by an insect, and that's Hessian fly. At that point in time, it's too late. But you get rid of the volunteer wheat, that will really help reduce your Hessian fly problem. Also, we talk about mites. There are probably 3 different mite species in Kansas that we worry about. The 2 least are the wintergreen mite and the brown wheat mite. Those are mites that can cause damage, especially under dry conditions, because mites, they suck the juice out of the plant cell by cell, and if the conditions are not good for growing, sometimes in the fall that can, set back the wheat. Probably the mite we worry the most about is the wheat curl mite because it does the same thing. It can feed on the plant juices and cause a problem, especially during dry conditions. But it can also transmit or vector a disease, which we've had a lot of in the last, it's been building up in the last 5 or 6 years around the state. It's generally considered more of a problem in the western, probably half of the state. But the wheat curl mite can vector wheat streak mosaic. Not all of the mites are infected, but it seems to me like most of them are. So if you have an infestation of wheat curl mites, you're probably going to have the disease. So the mites are non-winged. They can't fly. They can't jump. They can't run. They can float. They can't swim. So the way they get from one infected plant or one infested plant to a non-infested plant is crawl or by the wind, mostly by the wind, but they can crawl on adjacent leaves also. And that goes with wintergreen mites or the brown wheat mite. But the wheat curl mite is probably the one we worry about the most. In any case, Hessian fly, I forgot to say, they can fly. They're a fly. They can fly, but they're probably transported by the wind mostly also. But those are the primary pests we worry about as far as arthropods or insects or mites go in Kansas as far as getting rid of volunteer wheat.
Does getting rid of the volunteer wheat usually take care of them?
Yes. Now, when we talk about the Hessian fly, like I said, they are winged. They can fly. And a lot of times your neighbors need to take care of their volunteer wheat also. With the mites, generally that takes care of the problem. If you take care of your own volunteer wheat, you're probably not going to have a problem from the neighbors. But in the case of Hessian fly, I have seen, when I've been out to give talks, I have seen neighbors, complain about their neighbors not taking care of their volunteer wheat in a timely fashion, causing a Hessian fly infestation in theirs. But for the most part, if you get rid of your wheat that's voluntary, you will pretty much control your problems. And if you can talk your neighbor into getting rid of all their volunteer wheat, it will pretty much help everybody's wheat problems also as far as arthropods go.
Kelsey, as those things can be vectors, what do you see from the pathology side?
Right. So the key mite that Jeff just mentioned that vectors disease is the wheat curl mite, right? So that's the mite that carries around our suite of viruses that cause the wheat streak mosaic complex, right? And so like Jeff previously mentioned, this was a year where unfortunately we saw a lot of wheat streak mosaic complex pop up in that April timeframe, right? So, some quick reminders there. I'm talking about a complex of viruses because there are really three major viruses that we're thinking about here in Kansas. So we have the wheat streak mosaic virus, right? That's the virus that gives the complex its name. Then we also have another virus called triticum mosaic virus, right? And we've seen a lot more cases of triticum mosaic virus this year. So I wouldn't be surprised if you got a result back from the diagnostic lab and you had a field that was positive for triticum mosaic virus. That third virus in the complex is High Plains wheat mosaic virus, right? Now, it's important, right, that we're thinking about all three of these viruses, right? Because even though they all cause the same symptoms, they can behave a little bit differently. So the first most important piece there is that there's a lot of good data that shows that if you have co-infections, so if you have more than one of those viruses, so say you have wheat streak mosaic virus and you have triticum mosaic virus in the same plant, they result in synergistic yield loss, right? So in those cases, we can have higher yield loss than if we have single infections alone. And unfortunately, this year in Kansas, we saw a lot of cases through the western corridor and the central corridor of Kansas where we did have co-infections of wheat streak mosaic virus and triticum mosaic virus. The other important piece there, and one of the reasons why we're thinking about all three of these viruses, is that the varieties that we have out behave differently to these viruses. So, for example, we have several varieties that have a resistance gene called WSM2, right? So these might be a variety like KS Dallas, for example, KS Territory, right? They have this WSM2 gene. That's a gene that works against that virus, the wheat streak mosaic virus, right? So that's a good thing, right? We can get out there, plant a variety that has a resistance gene to that wheat streak mosaic virus. But unfortunately, a lot of those varieties have some susceptibility to triticum mosaic virus, right? So we've gotten a lot of these calls this year where we have a field, say it has something like KS Dallas that has pretty good resistance to that wheat streak mosaic virus, but it had symptoms in April, pretty bad wheat streak symptoms. Sure enough, it tested positive for triticum mosaic virus, right? So it's important for us to think about this virus as a complex. We have at least three, right? Those three viruses that I mentioned that are active in those curl mite populations in Kansas. And a critical piece is they're all going to be, those mite populations are going to be very active right now, right? So this is the moment where all of those mite populations that have those three viruses in a complex together are at their most active period, right? And they're looking for volunteer wheat, right? So at this moment when we harvest, we'll have maybe pre-harvest volunteer that maybe sprouted after some hail events that came through the state or some of these harvest delays. And that would be a most critical source for those mites to survive and bring those viruses with them through the summer and to our next crop.
That was K-State wheat pathologist Kelsey Andersen Onofre and K-State crop entomologist Jeff Whitworth. We're cutting to a short break now on Agriculture Today, but when we come back, we'll once again be joined by Kelsey and Jeff, and we'll also be joined by K-State wheat specialist Sarah Lancaster as we continue discussing controlling volunteer wheat. If you are reaching your destination and aren't going to be able to hear the rest of today's show, please remember that you can always find it by going online to agtoday.net, or you can search for Agriculture Today on your favorite podcast platform. We're cutting to a short break now on Agriculture Today, but once we come back, we'll be joined by Jeff, Kelsey, and Sarah. You're tuned back into Agriculture Today, and we continue our show discussing volunteer wheat with K-State's Kelsey Andersen Onofre, Jeff Whitworth, and Sarah Lancaster. Kelsey, as we think about the Hessian fly, are there any concerns with that?
Well, I wouldn't say Hessian fly brings good news, but the piece of good news from a pathology perspective is that there are not any known viruses moved around by the Hessian fly, right? So we're just thinking about pure Hessian fly damage, which can be severe, like Jeff mentioned, but we're luckily not thinking about the same virus complex that we're thinking about when we're worried about that wheat curl mite. I think an important piece is that there's a pretty big scale difference between the size of the Hessian fly and the size of the curl mite. So these curl mites, they're microscopic, right? It's very difficult to see them without a microscope or a hand lens, right? So you could potentially miss them, right? We could have hundreds of millions there at harvest, but you just wouldn't see them the same way you would see Hessian fly or even the other mites that were mentioned earlier on the show.
So does a Hessian fly just look like the normal fly you'd see?
The Hessian fly is a little tiny midge, the adult, and they only live 1 to 3 days. So you're not going to see the adults. You're going to see probably what they call the flaxseed. That's kind of a mahogany color brown little, that is the pupal stage of the maggot, because the larval feeding stage is a maggot, as it is with any fly. They don't transmit any diseases, but they're awful small, but they are a lot larger than the mites that we're talking about, especially the wheat curl mite. The wheat curl mite is very, very tiny. You can barely see it. If you know they're there, you can see them. Like we have them in our growth chamber. If I go take a leaf off a wheat plant that I know is infested, you can actually see them. But if you're just out in the field, you're not going to see them, especially when the wheat starts to senesce or turn yellow or gold or whatever you call it. So they are really, really tiny. They are moving around as the wheat does senesce or as it dries down, because they suck the juice out of the plant. As it dries down, there's no juice. So they start moving to looking for another source of food, and the wind picks them up and moves them. Like I said, they don't have wings. So you're probably not going to notice them unless they land on you. Or if you pick up a volunteer plant here and there and the leaf happens to be curled, if you uncurl it, you might see a whole bunch of little tiny cigar-shaped kind of a whitish, greenish, crawly things. That's wheat curl mite itself.
Do they usually move around in groups, or do they move around individually?
Yes. Well, they're not social. Like when they're all moving, looking for something to eat, there'll be bunches of hundreds of millions, who knows how many. But normally one will crawl to another plant. When we infest them, we just take a infested plant and lay it down into a pot with others, and they'll crawl off one at a time. So either way, they can either go crawl one at a time or the wind will blow, which is mostly likely the way they're transmitted.
I feel like we've established why we're not a fan of volunteer wheat. And so, Sarah, how do we kill it?
Yeah, great question, Shelby. Volunteer wheat control, we typically think about glyphosate, right, as kind of our go-to product for killing volunteer wheat. The next kind of tier of products that typically come to mind when we talk about controlling grasses would be the group 1 herbicides, so things like clethodim-based products like Select or Section 3, or maybe quizalofop-based products like Assure. Those are generally going to probably be a little more costly than some of the glyphosate formulations. Now, the thing about glyphosate and group 1 herbicides that maybe we need to reconsider things in terms of the mosaic virus complex is that they tend to work pretty slowly, right? We expect to see symptoms within a week to 10 days and our plants maybe dead by, 2 weeks time period. But, well, these two can tell you better. I don't know how many, reproductive cycles of leaf curl mites can happen in that 2 weeks time, but
a lot. It doesn't take them very long, 10 to 14 days they cycle through.
But there was some work done here at K-State several years ago that demonstrated that when we apply herbicides that kill the volunteer wheat faster, we tend to do a better job of breaking the cycle of those wheat curl mites. And so probably when we think about fast-acting herbicides for after wheat harvest, gramoxone or paraquat is the first thing that comes to mind. I recognize all the baggage that sometimes comes with making that recommendation. So that is an option. Another product that folks might want to consider would be products like Sharpen or Reviton. Reviton tends to have a little better grass activity than Sharpen. So those two herbicides are both group 14 or PPO inhibiting herbicides. They're contact herbicides, much like gramoxone. So coverage is going to be really important, and also getting the adjuvant package right with that is important. They're going to want both an MSO product and a nitrogen-containing product like AMS in order to maximize effectiveness. Another product that folks might think about for volunteer wheat control that will provide some residual activity is atrazine. We've been talking a little bit about atrazine in terms of more restricted application requirements, and that it can no longer be applied to like corn or grain sorghum stubble. There is still a label for use in wheat stubble, so it could still be useful for this application.
So while we're trying to break this cycle for these different issues, when's the best time for that, or the ideal time?
Right. Of course, we'd love to keep our fields clean all summer long, but sometimes that's, not practical. So we can think about maybe two critical windows, right? This first window is killing those mites that are coming off this year's wheat crop, right? They're going to make a big migration now, and the highest risk volunteer is going to be that volunteer that's present at or right around harvest, right? Those mites are just going to have to fall straight down and have a volunteer wheat buffet, right? And then we're going to look to that next most important window, which is really our pre-planting window, right? We definitely want everything dead, within 2 weeks of planting. And that's really a regional recommendation, right? So 2 weeks of when you're planting or your neighbors are planting, we really need that mite bridge killed. Again, those mites, they can do really well on volunteer wheat, but they only survive about 4 days on a dead host, right? So it's really important that everything's clean before we're planting.
We've talked about controlling just wheat, but do we need to worry about controlling other plants around the field as well?
Yes. As I said, the Hessian fly and the mites have alternate hosts. They're secondary hosts, whatever you want to call them, like a grass. Wheat's a grass, so they can utilize grasses for a short period of time. They don't do as well. They don't build up in the massive populations as they do on wheat, but corn, sorghum, these mites can live off there for a little while. Hessian fly can live on barley and rye and some other crops. They're not as well. They're not as well adapted to those, but they can survive for a while. We talk about the mites that are coming off wheat during this period of time when it's senescing or just getting into harvest, there's a lot of bare patches in fields that the guys have been planting. You don't realize that's where a volunteer will exist. And these things, as the wind blows them, they can get in there and exist for quite a while. As we said, they're awful small. They're really tiny. So it just doesn't take a very big patch of volunteer wheat to produce literally hundreds and thousands and millions of mites or even Hessian fly. Hessian fly can be, 15 to 20 per plant. So, yeah, there's some alternate hosts, some secondary hosts, whatever you want to call them, but they're not as good as wheat.
On that topic, one place we do sometimes see hidden volunteer, right, is in, our summer crops, right? So sometimes it's hard to control those secondary flushes of volunteer in your milo crop or in your soybean crop and in cover crops, right? So if you're following your combine with a summer cover crop, it's hard to control your volunteer there, right? So there are some maybe sneaky places where we're seeing mites survive, and it really doesn't take much volunteer for those mite populations to build.
And we did a study all across the state several years ago where we sampled wheat for the viruses, barley yellow dwarf virus, which is transmitted by aphids, and the wheat streak. And even though we generally think of these as more problematic in the western, half of the state, we found it all the way across the state. We just sent a graduate student down I-70, and every so often they stopped and took wheat, put samples in, and we came back, and one of our former colleagues, now retired, Dr. Mike Smith, he sampled them and found the viruses all the way across the state. So if you have the mites and if you have the aphids in the case of barley yellow dwarf, you might even come up with a disease. So there you go.
What's your recommendation for people if they have questions about controlling volunteer wheat?
Call these two young ladies. They're great.
From a herbicide perspective, Shelby, the Chemical Weed Control Guide is a very useful resource, I do believe.
Always reach out to your local K-State county unit. There's great resources available through the Agronomy e-update. And we do have a plant disease diagnostic lab here at K-State. You can connect with it through your local county extension office. And we do test for all of these viruses that we mentioned, the wheat streak mosaic complex, barley yellow dwarf, and a couple other wheat viruses. So you can get a whole virus panel there through that K-State diagnostic lab.
Kelsey, Sarah, Jeff, I appreciate you all taking the time to join us today.
Sure.
Thanks, Shelby.
That was K-State wheat pathologist Kelsey Andersen Onofre, K-State weed specialist Sarah Lancaster, and K-State crop entomologist Jeff Whitworth. I will link the resources that they mentioned in today's show notes on agtoday.net. We're cutting to a short break now on Agriculture Today, but we'll be right back.
From Kansas State University, this is Agriculture Today over the K-State Radio Network. Along with Shelby Varner, I'm Jeff Wickman. We end today's program with this week's milk lines. Having just a little bit of dust collect on fan blades and the housing may not seem like something that requires immediate attention. However, that little bit of dust may result in 30 to 40% less air movement and increased electrical costs. K-State dairy specialist Mike Brouk says that keeping fans clean and well-maintained throughout the summer can significantly reduce energy costs on the farm. His suggestion is to clean fans once a month or at least every other month.
Today I'd like to visit with our Kansas dairy producers concerning electrical costs during the summertime. Most of you have probably realized that your electric meters are spinning very quickly with the increase in temperature. Part of that is due to the increased amount of electricity that we utilize to cool the milk, but a majority of that is actually associated with the use of fans to cool our dairy animals on our farms. So when we think about fan electrical use on most of our dairies, it can range from about 20 to 25% of the total electric usage of a dairy, depending on whether or not you have barns that have tunnel or cross ventilation where you're dependent on constant fan usage to cool as well as ventilate those facilities. So your actual electric cost for the housing unit and fans may actually be a little higher than 25%. It just depends. But with the increase in heat, those requirements go up. So how can you control that? Well, as I travel to various dairy farms, one of the things I often notice is the fact that we don't do a very good job of fan maintenance. And I know it takes time, but please understand that fans that are poorly maintained actually move less air, and they also consume more energy. So what are some of the things that I'm thinking about? Well, the number one issue that we generally have is the fact that the fans are dirty. As little as 1/8 of an inch of dust accumulated on the blades and on the housings of the fans can actually reduce their movement of air by 30 to 40%. This is very, very significant because at the same time, they also will consume more energy. Again, sometimes as much as 30% more, while moving less air than what they should, just because they have accumulated dirt and dust. Depending on where your fans are located in your barns, as well as holding pins, will determine whether or not we have excessive accumulation of dirt and dust on those fans. Anytime there's water spray involved, we tend to have more of a problem and thicker buildup. So we need to clean those fans, and often I'm asked, how often should we do that? Well, a great thing would be able to clean those fans about once a month during the summertime. If you can't get it done once a month, at least every other month would be important. Keeping in mind that when we get dirt built up on the fans, particularly on the motor housings, those motor housings actually operate at higher temperatures. As they operate at higher temperatures, that causes increased wear on the electrical components as well as the bearings. So keeping those motors and the motor case as dust-free as possible is very, very important. As you also think about your dairy and how you can more efficiently operate during the summertime, make sure that you also keep the compressor coils cool on your milk cooling equipment. Oftentimes during the summertime we see dust collect, and in some cases maybe even sand collect on the fins of these condensers, and it's important that we wash them often and make sure that they remain free of debris and things that block the flow of air so that our compressors are more efficient as they run as well. This is Mike Brouk with K-State Research and Extension, encouraging our dairy farmers to do what they can to increase maintenance around the dairies so that they can reduce energy costs and improve the cooling of the cows and the milk.
Thanks, Mike. And that'll do it for this edition of Agriculture Today. For Shelby Varner, I'm Jeff Wickman. This is the K-State Radio Network.